Hi guys. I thought you may have some trouble on the Pythagorean Theorem challenge, and so I thought maybe going through one of the questions would be helpful. So I picked this one. If there's a different one that you might want to see, just let me know. This one says the tetrahedron super yacht, designed by Jonathan Schwinge, is a regular tetrahedron with edges 20 meters long. The distance r from one corner to the center of the base, shown in the picture below, is 11.5 meters. So a tetrahedron is a pyramid but has a triangle base. So what I did, because I thought this picture, this guy here might be a little bit tough to see. So I So what I did was I just found a picture of a regular tetrahedron that might be a little bit easier for us to draw on. So it's like I said, a pyramid with a triangular base, and it says it's regular. Now regular, remember, means all sides the same length. Okay. So that means this bottom triangle, although we're looking at it from like a weird perspective, but this bottom triangle is equilateral. So like, oops, I pushed a button. I pushed lots of buttons. Don't do that. Go away. Delete. Okay. So that means this guy is 20, this guy is 20, and this guy back here is 20. Okay. I'm gonna actually get rid of the one that I just put on there, this guy in the back, because I don't want inside stuff to get confused with outside stuff. Okay, then it says the distance r from one corner, so I'm going to pick this corner, to the center of the base, this distance here, okay, is 11.5 meters. So that guy's 11.5 meters, and I probably should put meters so we know what units we're working with. Okay, and it wants to know what is the vertical height of the tetrahedron, which is really just like how tall is this yacht. Okay, so that height is going to go all the way from the apex of the pyramid down to the center at a 90-degree angle. Okay, that's what we're looking for. How long is that? So what you hopefully will see, or what's created, is that between this line, and this line here, this edge, right, we've got this right triangle. Okay. So what I'm going to do is read, what did I do? There we go. I'm going to redraw that right triangle, right, where this is 11.5 meters. That's a right angle. We want to know H, and we have to know that length in order to be able to find the height, right? So we have a piece of missing information. We have to decide how are we going to find that. Now, since it's a regular tetrahedron, not only are all the sides of the bases 20 meters, but all the edges are 20 meters. So this one that we hadn't labeled before, this like unknown, is actually really just 20 meters. Okay, so we have a right triangle, we're looking for the height. So if we're looking for one side of a right triangle, we can use the Pythagorean theorem, a squared plus b squared equals c squared. So remember, c is always your hypotenuse, and then a and b doesn't really matter. Okay, so I'm going to say a is 11.5, b is going to be h, and c is going to be 20. I'm just getting my calculator. So 11.5 squared is 132.2. Oops, pushed a button. Man, I'm not batting 1,000 tonight. 132.25 plus h squared equals 400. All right, so we're going to get rid of that 132. So we've got 267.75 And then to get rid of squaring, we're going to square root both sides. Which means I actually have to go to the calculator. Oh, that's fine. And square root it. Okay. And when I square root it, it's now I know 16 squared is 256, and 17 squared is 289, I believe. So this is definitely going to be between 16 and 17. And since it's a little bit closer to 256, it's going to be closer to 16. So it is. It's about 16.363 ish, right? So if we had to round it to the nearest tenth of a meter, I would round it to 16.4 meters. Okay? So I hope that thinking about it that way is helpful and that you guys use this video to help you do what you need to do. Can you tell I'm rambling at this point? I am. Okay. I hope you guys have a great day. Bye.